Okay, welcome everyone, and thank you for joining us for this webinar in our manufacturers series presented by Wisecon entitled How to Incorporate Automation into Your Agricultural Irrigation Business. Our speaker today is Guillermo Valenzuela. Guillermo is a co-founder of Wisecon Engineering, a Chile-based company focused on deploying IT solutions for efficient water management. He received his business degree and MS in marketing from Universidad Adolfo Ibanez and the Copenhagen Business School. The culmination of experience on water distribution, working with irrigation districts, and automated irrigation control on a heap of leaching operations and copper mining is what sparked his involvement in agricultural irrigation 15 years ago. Today, he is the VP of Sales and Marketing and the President of Wisecon Engineering based in Fresno, California, where he's been working with local growers and researchers at Fresno State and the University of California Agricultural and Natural Resources Center in Kearney to improve irrigation efficiency through management and control. And now over to Guillermo.
Thank you, Mike, for the presentation, and thank you for the IA to allow us to host this webinar and kind of like spread the seed a little bit on what we've been doing. I'm here to introduce how to incorporate ag automation into your ag irrigation business. But since the audience is a combination of people of growers and installers, distributors, manufacturers, I thought of presenting something that is a little bit more broad and shows kind of the whole spectrum around automation. So I'm with Wisecon, and the topics that we're going to go through, I'm going to talk a little bit about the company, just for those of you who don't know it. Then we're going to go into what is automation and to do a definition of what we consider, which is a complete automation solution for ag irrigation. Then we'll go through some very simple use examples that we have here in the US on how you can pay for growers can pay for their investment using this technology. And then we'll dive into more of a irrigation business discussion, the considerations to add automation into the business, pricing and examples, and finally some marketing and funding recommendations around it. So first, Wisecon. We are a Chilean company, as Mike mentioned. Was founded back in 2006. We started working on water distribution and automating heap leaching pads and copper mining, and that led us to get involved in ag and develop our product DropControl and launch it to the market in 2012. We opened an office in California in 2015, and we've been headquartered there for the US since then. We got our support department there, and we got a warehouse in Fresno, California. We are currently working with around 15 distributors in USA, mostly in California. We've expanded outside of the state in the last couple of years. We've deployed about 200,000 acres, 8,500 units or nodes or RTUs deployed with more than 2,500 users in 5 countries. In overall numbers, we're currently operating about 1,000 pumps, 16,000 valves, and about 2,500 to 3,000 soil moisture sensors. In the US, as I said, we're currently very present in California. That's where we worked, focused on for the first 3 years. And since last year, we started expanding abroad, and now we're covering states like Hawaii, the Pacific Northwest, Washington, Oregon, and Idaho, the Southeast with presence in Florida, Georgia, and most recently in the Central States, working on cotton and corn and subsurface drip irrigation. So today we're here to talk about how to incorporate automation into our agricultural irrigation business. So the first thing I wanted to start by is kind of like defining what's the state of the art. Currently, and I like to use this metaphor here, irrigation systems are deployed without remote control to the TV, basically. We are, as an irrigation industry, are providing many manual operated systems, which is kind of like selling a brand new 80-inch flat screen TV without a remote control, having to stand up from the couch to change the channels or change the volume. And that is the same that happens here on irrigation. We're providing a solution which is a high cost solution for growers without the ability to control it remote. And that is the first concept that we need to consider when we're when we're thinking on adding irrigation automation to our ag irrigation business. We're adding a component that is not the highest price, is not part of the main structure that we install, but is crucial for the user, and it's a must nowadays. How do we do this? We do it through our product called DropControl, which we define as an online irrigation management system. And according to NRCS, irrigation management is a process of determining and controlling. So it's both determining and controlling the volume, frequency, and application rate of irrigation water in a planned, efficient manner. So we're talking about concepts that we're going to be touching throughout the presentation: making a decision, determining, controlling, executing accurately, and being efficient with the water use. What we have is DropControl, which is a reliable irrigation monitoring and control system, able to connect to any sensor, operate wireless valves, pumps, and injection systems through an easy-to-use online software. So this is a solution which is basically a holistic approach to irrigation. It covers the problem from the water source to the soil moisture sensor, from the well to the reservoir to the booster, filters, fertilizer injection pump. So what the system is capable of doing is basically taking control of the pumps, either electric or diesel, monitoring your flows, pressures, backflush control, reservoir level control, groundwater level monitoring, energy consumption, anything related with the pump and the filter station. Then, of course, in the field, crucial for efficient irrigation management, valve control and valve feedback, which is a key part in order to make sure that the system is operating reliably. So valve control and valve feedback from the field. Fertilizer injection, very, very popular nowadays, getting more traction on precise nutrition and fertilizer injection, acid injection. Weather station, again, we're determining and controlling. So we need to be in knowledge of ET, rain, temperatures, all the information that is relevant for irrigation decision making, including, of course, soil moisture sensors, a key part of the irrigation decision making. And then, of course, plant sensors in any shape or form. We've worked from leaf temperature sensors to dendrometers, fruit size sensors, NDVI sensors. There's all sorts of sensors on the plant that help make an irrigation decision better. And all this from a centralized control on your phone, on the cloud, through a web page. But we also always provide and override a local alternative. These technologies rely on radios, relies on cellular communications, and the fact of having the capability of controlling it locally and overriding the cloud and being able to irrigate, even if the cellular is having issues, Verizon is down, or AT&T or T-Mobile, any preferred brand, then we need to be able to operate our irrigation systems locally. Now, how this works is that we deployed units throughout the field that are connected to the sensors, to the actuators, and they take control of the system. They communicate between themselves through radio, and then one of them that we usually call the gateway is connected to the cloud. Now, this unit is syncing the cloud with the field. It does not need to be constantly connected or constantly in communication with the cloud. The logic and the hydraulic intelligence of the network that we have developed and patented is what allows the system to operate independent from the cloud and collaboratively between themselves in order to operate reliably without human supervision. So the solution is composed of two parts, the hardware and the software. In terms of hardware, we have three models. We got the M1, which is the monitoring node, the X1, which is what we call the flexible node. That is, it's kind of our bread and butter and what we've deployed thousands of units of. And this is the unit that's capable of monitoring and controlling devices in the field. And then most recently, we've deployed in the market our C1, the pump controller node, the one that has more processing capabilities. It's got Bluetooth connection. It's got filter flushing capabilities being released now. a screen is also coming into the market for local control for those operators that don't have a smartphone. And it's got very high fertigation control capabilities in order to do precise nutrition injection for specific crops, substrate, or hydroponics and other applications. So the M1 is the monitoring node. It can be either radio or cellular, so it can go straight to the cloud or be part of a radio network. It can connect to multiple sensors of different protocols. Our system is bare wire open protocol, so you can connect any sensor to them. You just go in through the cable gland, bare wires into the terminal, so you don't need any special connectors. You can use existing sensors or infrastructure that's already in the field. And then we got a variety of protocols like SDI12, RS-232, digital, and analog for 20 milliampere, for example, that are already included in the node in order to connect all sorts of sensors on the same unit. The unit incorporates the battery, the solar panel, the mounting bracket, so you don't have to be incorporating a power management solution, a battery, a solar panel. That all comes in a package. All of them come with their communication device, with their solar panel, with their battery. Then we got the X1, which is the flexible node. All of them come with a radio. They can all be part of a network, and they can also be a gateway, so they can be both radio and cellular. This one can be a gateway to the cloud. It's got 5 slots on it, so you can install different expansion boards with different communication protocols or actuation protocols, which include 12-volt DC latching, relay control, sensor protocols. So it's very flexible in that sense that you can connect multiple sensors and multiple actuators. And in this case, the sensor also comes with its own battery. It's incorporated in this top part. It comes with a solar panel with their mounting bracket, so it's ready to go out of the box. And then finally, the C1, the controlling node, as I said before, is a more intelligent device. It's got more capabilities. It can be radio or cellular or both. It can expand up to 70 IOs. It comes with 10 inputs, 10 outputs, and some analog inputs and serial inputs in order to communicate with VFDs or energy monitoring systems, pressure transducers, etc. But it also has expansion modules that allows the designer to incorporate and expand the same unit up to 70 IOs and controlling up to 5 irrigation systems. And then, of course, we have all the accessories. This is crucial that you are a one-stop shop and you can have everything that they need to get your platform running, and you don't have to go send them buying antennas somewhere else or batteries. All that is included in our catalog, and you can buy high-gain antennas, extra batteries, extra solar panels, or anything that you need to get the system working properly. In terms of the communication, we have a bidirectional mesh radio network communication. It's on a 900 megahertz spectrum, so we have a very flexible communication port, so we can replace that from 900 to cellular to LoRa to Sigfox, narrowband IoT, you name it. Right now, we feel very comfortable with 900 megahertz because of the speeds and the uptime that the protocol has, and then LTE in the US, mainly using for the cloud connection. Some countries like Mexico or South America, we're using 3G, which is what's most stable cellular connectivity in the field. The radio communication has a 2 miles line of sight range. Each node works as a repeater. It's true mesh. They self-heal and repeat, so you can reach up to 20 miles with 10 repetitions. And then the cell provider, as I said before, can be any provider available in the ranch, because the LTE modem is configured to operate with any of the major carriers. In terms of sensors, we're agnostic. Usually what we do is connect, as I mentioned before, so moisture, weather, pressure switches, transducers, pH and electric conductivity for the nutrition part, plant sensors, flow meters, etc. Now, we have our preferences. We have sensors on the catalog, but we tell our integrators they can go buy their sensors anywhere, and they can buy or the grower themselves, they can go buy any sensor anywhere off the shelf in Amazon, and as long as they are an available protocol and it's bare wire and it meets the technical specifications, it can be connected to the nodes. And in terms of nutrition, it's the same thing, and actuators in general. We do carry fertilizer injection pumps. We have these pumps because they have certain intelligence. They have a variable frequency drive incorporated in them, so you can run them at different rates, change their speeds, and they have certain intelligence that allow us to control them and do a very precise job on the nutrition injection without having to count on a big skid with venturis and flow meters. Although we are agnostic, we automate skids and venturi-based systems as well. In terms of the software, well, we got the field, as I explained before, and that the field is connected to the cloud, synced to the cloud through the cellular network. And then when you're in the cloud, we have our own app, which I'm going to briefly show right now. And then we have a WAS, which is the Wisecon open service. It's a free app, and it's the one that our installers and integrators use for configuration, testing, all that. And then we got an API, which is to connect to third-party platforms, which has become very popular lately. And we've been doing very interesting integrations and incorporating the brain to the solution. We don't provide the brain, we provide the remote control, but when we partner up with these API companies is when we bring in prescriptions and recommendations and close the loop and execute the recommendations in the field. That is what's been happening, what's the latest and what's the newest thing that has been happening on the irrigation automation space. On our side, we have an app. It gives you the bird's eye view of the map of the ranch. It gives you your soil moisture sensors, evapotranspiration, irrigation information, and detail on what has been occurring in the field. And you can, of course, schedule from the app to run the irrigation. It also gives you notifications. So a lot of people just rely on the notifications on the app telling them when the pump started, when the pump stopped, if there's any alarms or any anomalies or anything going on in the field. And then, of course, a web page for those that want to dive deeper into the data and the information and operate this from an office. We have big farming operations operating currently this from a central location and have a person dedicated to it and looking at scheduling and analyzing the data on one centralized location. Very easy to schedule. You go through, add your hours or your volume. You can do a volume-based irrigation, your fertilizer injection that can be done by time, volume, or even proportional based on the amount of water running through the main pipe. You can inject the fertilizer, spoon feed the fertilizer into the line. And then acid injection, also we have the capability by monitoring the pH, controlling the speed of the pump injection, and maintain a certain pH in the water at all times without having to guess or inject the acid based on a simple water sample. We are constantly monitoring the pH and injecting the acid based on the actual need. It allows people to build programs very easily, set up templates, and then have the system automatically schedule for them. And then it gives you the feedback. It shows you what you scheduled on the top, and if it was an irrigation or a fertigation or a manual irrigation, an override done in the field, it identifies it with a different color. But on top it shows you what has been scheduled, and underneath what really happened. So in this case, it's an irrigation that was supposed to run from 7 to 12. It was executed okay, but instead of running at 1,200 gallons per minute, it ended up running at 1,100 gallons per minute, would basically put out an 8% volume difference. We can get, and we've seen a lot of high frequency irrigation. This is a daily view that allows to see on a blueberry substrate production where they're running 12, 13 times a day, fertilizing each one of them except the last one where they just put clean water to clean all the lines. And you can get the daily view as well as the weekly view to understand how many inches you've scheduled and how many inches really executed, so you can see where you are at on a weekly basis on a difference between what you scheduled and you planned versus what really happened. And then, of course, there's all the sensor feedback information, flow meter readings. This right here, it's big farming operation monitoring their flows. This is in CFS. And then in black, you can see the accumulated volume in acre feet per week. And then the red line is basically showing you the totalizer of the flow meter on acre feet. So I can match what my screen is telling me with what the software is showing me. We also have pressures where we're doing a constant distribution uniformity test, monitoring the pressure on the main line. Here by the filter stations, you can actually see the backflushing events. Then on the sub-mains, all the way down to the drip line, especially on those further spots or where we design the system to have a lower pressure. If there's a soil moisture sensor there or a valve there, you're going to add a pressure transducer to monitor how the pressure is distributing throughout the irrigation system. So moisture sensors for irrigation decision making, determining how long and how frequent you're going to irrigate, and then alarms, getting alarms, texts, emails, even phone calls for frost control. So if there's a frost event, especially if you're controlling it through water and irrigation, your frost control method, then the system can give you a phone call and wake up anybody that needs to be waking up during the night if they're not ready for frost control event. And then finally, on the software side, as I was mentioning before, kind of the new wave and what's been going on is API integrations. We've already integrated with 7 companies that provide different services and different solutions, and basically get to the field through our platform. So companies like Phytech that do irrigation prescriptions, Semios, Powwow, and FarmItRx are companies that are providing irrigation prescriptions based on different methods, different models, different algorithms, different sensors. But they come out with a prescription and send that prescription into our system, and we basically automatically define a program, a schedule, and then execute it in the field. And then on the other hand, we got companies like Swim that are doing the water reporting for regulation purposes, or Polaris that do automatic demand response or energy management in order to pump water when it's best in terms of energy cost. And then as well, you know, common sensor companies out in the market, or here in California, we have CIMIS, the California Irrigation Management Information System, which we pull the data from, or if there's a Davis weather station out there, we just, through their API, we bring in the information into our platform and consolidate the information without even touching their sensors. This is an example of one of the API integrations that we have with FarmItRx, company based in Fresno, California. They have a model that incorporates sensor data, imagery, soil sampling, tissue sampling once a month. So they have a whole concept on building up the irrigation schedule. And what we do is basically upload all that information to our platform into the cloud. Then they put it in their servers, put it in their algorithms, in their blender, as I call it, run the blender, and when that prescription is released, then the grower approves it and we execute it in the field. So why drop control over other solutions? Well, some of the things that I've already explained. The control architecture is what we patented, the fact that it does not rely on the cloud or does not rely on a central location to operate reliably. The irrigation schedules are sent from the cloud to the field ahead of time, saved on each one of the devices. And that's what's allowed us to build our reputation of being a reliable automation system and all the acreage that we're all currently working. We are combining all the irrigation related tasks in one platform, from the water source, from the well, from the canal, all the way into the drip line, the soil moisture sensor, the pressure switch, or the pressure transducer at the drip line level. The software capabilities and ease of use, we've had outstanding acceptance in the market. We got, irrigators, multi-language irrigators running the app, scheduling in the field, easily learning in a matter of hours or days. And then on the other hand, we got management, grower, farm management companies or owners or the management going over water balance, going over irrigation strategy, going over agronomy at the software level. So we've been able to incorporate the ease of use and the agronomy into it. Everything is configured remotely. The firmwares are updated remotely, and we diagnose everything remotely from our central location, where we have a support department, a help desk, and where currently we have 5 people sitting in Fresno just to support installations and users and farmers. These guys are geared up to receive 2,000 phone calls a week, and we're right now basically working on helping out everybody get their systems tuned in and running and operating them, or even sometimes it's as simple as forgetting a password. We're there to support. Another differentiation is that we're open to any sensor in the market. It's off-the-shelf components. We don't have any special connectors or anything. So even sensors that you might already have in the shed from a past attempt on using soil moisture or weather can be connected to it. We're open on the API side, so we're connecting to all these third-party softwares that are coming out with great technology, great model, great artificial intelligence. We are not providing that. We are not telling growers what to do, but the grower can choose who to work with and will be connected to them. Then the complete support network and training resources. Our dealers are all trained, are all knowledgeable on how to use the equipment, on how to install it, how to service it, and then support their growers on using the platform. And then finally, competitive pricing is always important to be able to come out with a solution that it's affordable, that it's considered by a grower in an irrigation project. So pricing is a very important part as well. So I'm going to jump into some use examples. This is what we've been seeing here in the Central Valley of California that's been happening a lot on the nuts. It's high frequency irrigation. For several reasons and benefits that, depending on your soil type, high frequency can work very well. This is an almond orchard in Chowchilla that had to change their strategy once they ran out of water. During the drought, they lost a well and they went from 500 gallons per minute water source, from 1,000 gallons per minute water source to 500. So basically half the water. So what they did is that they started doing high frequency irrigations on 60 valves that they have on 170 acres and operating them several times a day, 3, 4, 5. Now they're even up to 10 times a day on their newer blocks. So this is one day where they were running on the adult trees 3 times a day for an hour, and on the younger trees 10 times a day for 20 minutes. What we've been seeing is that it's a very intense irrigation method. They're basically irrigating, in this case, the first 18 inches. So there's no water there in the deeper soil as an excess or as a backup, but it's very efficient in terms of use. So you're irrigating kind of like substrate but in soil. Their soil moisture sensors here are very important because they allow them to have visibility of what's going on under the soil and adjust either the frequencies or the durations. In this case, as I said, it was 170 acres. They're now running with 600 gallons per minute. They have 30% water savings compared to what they were doing before they started with this strategy, and averaging 3,000 pounds per acre with some trees that are 30 years old. On the other hand, the grower here experienced a big time savings because he didn't have to go out there and switch sets every time he wanted to change, especially if he was doing high frequency because he didn't have enough water, and that's the strategy he wanted to go with. Basically, it was a full-time job driving around opening and closing valves. And then the final thing is it's even water. There's no ponding, there's no runoffs. These guys are spraying 12 hours after they turn off the water. They're harvesting the day after they turn off the water. So yes, there's not a lot of water excess in the soil, so you have to be paying close attention. But on the other hand, it gives you very good benefits of being able to work on the field only hours after irrigating. And this is some pictures of UCNR and the almond board visiting the field and validating that this irrigation strategy was successful. The trees were very happy and the water use was below the average. So after that, other guys started to jump in with big blocks. This is a 800-acre farm that has 150-acre blocks, and they do also pulse irrigation. They went from once a week to twice a day, and what they've seen is that it's a 50% water savings on their results. But most important, they improved their production by 38% on the off years. So now they have a very constant production on pistachios, and they're producing around 3,000 pounds per acre on average. This is another example. It's out of the high frequency. Now we go to per variety on almonds. There are different varieties. So basically automation allows you to separate the pollinators from the non-pollinators, and you can irrigate them separately when you're harvesting or shaking. So the piping and the design, of course, needs to be set up for this in order to be able to open and close the valves depending on which variety you want to irrigate at that specific time. So as you can see here, we have the blocks on the left and these guys divided the ranch in two blocks, blocks 1A and blocks 1B-C, but then also they have block 1 Monterey, block 1 Nonpareil, and block 1 Sonora. So they have the capability of scheduling it to run as a block or per variety. And just to be sure, and this is a ranch that have 75 valves on it, so these guys decided to go with a pressure transducer after each valve in order to be able to check that the pilots and the pressure regulation was constantly operating and operating correctly according to their calculations, just by monitoring the pressure after each valve. If a valve loses pressure and the pilot is not regulating accordingly, then they can't tell that until the trees start showing it. So just by being able to identify that change on the pressure regulation, which it happens ahead of time, or as soon as it happens, you can correct it immediately, and the economic impact on that pays for the transducers, the service, and most of the system. This is another case that we've operated in the last couple of years. It's valve sequential operations in winters in California. This is also almonds. In this case, we found that we had two pumps, a north pump and a south pump on this ranch. The main pipe was on the west. It was a big pipe, high velocities, and the variable frequency drives connected on both the electric and diesel. And what happened on this ranch is that the filling of the pipe and filling of the actual block was from west to east, so it took a lot of time. And the velocity of the water, being the pipes big and how it was designed, it basically had pressures going all over the place. So what would happen is that the operator would start the pump, open the first 4 valves of the block, and then when he needed to change the set, he would open the other 4 valves and then go and close the first 4. So what started to happen in those cases is that the pressure would drop, the VFD would ramp up, velocity of the water would go higher, and it would take up to 30 minutes to go back to a regulated pressure on the whole system. And these people was looking into doing high frequency irrigation as well. They wanted to do 1-2 hour sets, and when you're doing that and you got 30 minutes to stabilize your pressures, it doesn't work. So the field was not doing very well, and what we decided to work out with them was do a sequential operation, meaning you open the 4 valves and then you start switching them one at a time. You open one and you close one. Then 5 minutes later, you open one and then you close one. And that sequential operation allowed the pressures to stabilize and the system to always run full pressure, which is what the emitters needed. And this was installed mid-season 2019, and we can see the vigor today. And this is an image from the last 3 years in May. Was absolutely incredible, and the ranch had very good results in terms of harvest. It was even, canopy, everything. It was really good results just by doing a tweak on the operation of the system, by incorporating automation, and the economic results were incredible. This is an example of a vineyard in Paso Robles, where they have a house there and a water tank that feeds the house for the domestic use. The well is down in the south, and what happens here is that you got 2 position valves. One is filling the tank, and the other one is going to the irrigation system. And the way this integrator did it here, we see the node and we see the VFD, and what they did is that they put a normally open valve going to the tank with a level sensor here, requesting water to the well when the tank needed to be filled. But then when the irrigation moment came, it will close the water tank valve and open the irrigation valve, and then control the field valves at the block level. So they had that capability and the intelligence just by using one node in order to feed the water tank and feed the irrigation system, and of course control the valves in the field when they wanted to irrigate the 4 blocks. Another thing that we've seen, I was talking before about high frequency. The other one that is a very good use example is variable rate irrigation, or VRI, where we've been seeing growers, especially on their new setups, they build their irrigation systems and they ask the installers to design the irrigation system matching the soil type. So we got, you can see on the sandy soils, that yellow stripe that goes there across the field. And here on the picture on the right, we can see from Google Earth that block had been irrigated right when the picture was taken. So that's why it's wet. So the irrigation system matches the soil type. And that has proven to be a very good investment. It does not cost a lot more to install an irrigation system like that. It's not a dramatic difference. We've seen everything from 10 to 25% difference on the cost of the initial investment, but the results are incredible. You're now irrigating your sandy soils with high frequencies, shorter durations, and your heavier soils, longer durations, lower frequencies, and your ranch and the trees and the crop basically looks even. This farming operation started off with these 80 acres and then converted around 1,000 acres to VRI because of how well it performed in the field and the trees. This is another example of another strategy using automation and monitoring, and again, a complete water irrigation management. This is walnuts in South America. Some of these are actually planted on hills, and that's another topic. If anybody wants to talk about that or has any questions about that, I'm happy to answer outside the call. But what these guys did here is, or what we worked out with them, was basically changing their irrigation strategy on post-harvest. Right now we're in the middle of post-harvest. What I've seen is a lot of people trying to put a lot of water on it because of the stress the trees went through for shaking. I've seen a lot of people wasting water because they're running wrong runs, which only just make the water percolate and not really being used by the tree, other than doing what we did here on this is the difference between 2011 and 2012 on a soil moisture sensor, where we can see right at harvest they stopped the water and didn't start it again until the rain hit. And the year after that, what we did is that we did some post-harvest irrigation and didn't soak the soil, but did several irrigation events to make sure that the tree could drink as fast as they could to recover from stress. And over a 2 to 3 year period, this is 2011 to 2013, was a process, but the root development was incredible. And since the tree didn't have the fruits anymore, all the energy went into developing roots, and the results were amazing just by managing post-harvest irrigation. Finally, this is an Avocado Ranch here that I like to show. This is a very interesting case study that we worked on as well, because we had two different blocks, a test, a control and a treatment, and we were controlling the one with the soil moisture sensor and higher frequency irrigation compared to what they were doing, which is whatever they did on the rest of the ranch. And we could see that the harvest was exactly the same. Both blocks got really good harvest, about 20 tons per hectare in this case. But you can see the water use on scale. This is 400 millimeters. So there was months that they were hitting 300 and something millimeters, where on the control, on the treatment side, we never passed 200 millimeters a month. So it was basically 50% less water with the same production. And when you're irrigating hills with the energy cost, this was a big impact on this ranch. And then finally, regulations are coming or are here. SGMA for California people, the Sustainable Groundwater Management Act. We've deployed by now hundreds of well monitoring systems. Same thing we're doing in Chile, in South America, and in general, where the government's starting to put regulations and online monitoring on wells. So that's also part of this holistic approach, where I'm monitoring my water source, I'm managing my wells, I'm running the wells that are more efficient energy-wise usually, or that have more water availability. But being able to report and have all the information that I need for regulatory purposes. Okay, so that's some of the information, considering what is automation, how do we use it, some example cases. But here I added some slides that are more targeted towards the irrigation business people that are looking into, or what do they need to consider when they're thinking about adding this business line to their operations. And the first thing, as I've already mentioned and gave examples, is understanding the ROI. This is something that it's usually very competitive in the irrigation project. On an ag irrigation project, this might account from anything between 5 and 15% of the project, but the impacts are huge. And what we've seen is that the water savings, energy savings on pumping, labor savings, because now you don't have people running around opening and closing valves, and the ultimate impact of increasing the yield and the quality of the yield pay for the system in less than 2 years. So we've seen anything from 5 to 10% increased production, all the way up to the walnut case I was showing on post-harvest irrigation management. Those guys increased their production by 30%. They had to use more water, yes, but the production was paid for the water and everything else. But on most cases, what we see, it's something between 20 and 30% water savings. And that's all the costs around irrigation water, meaning energy, labor, pump depreciation, or irrigation system depreciation, etc. So this is generating very big impacts on farms, and this is here to stay. And I've heard from growers that they want to work with the irrigation companies that are already working with automation systems, because now this is the way that the things are going to go, especially on our new developments. What to expect from the manufacturer? This is very important, and it's overwhelming. There's a lot of solutions out there. There's been a lot of smoke in the air, I like to say, companies coming out of Silicon Valley without real knowledge around, the problem, the ag and irrigation. So it's very important to understand and decide who you're going to work with and who your vendor is going to be. And this is kind of the considerations I think that need to be taken for making a decision. First of all, the equipment needs to be reliable and durable. The reliability and durability is what the grower expects. The grower expects a tractor to last 20 years, an irrigation system to last 20 years. So we're talking about systems that have proven track record, that have been in the field, the technology has been validated, and they have at least 5 years of operating examples. Because, that is a must. It's a requirement for you to be successful in this business. Then the simplicity, as I was saying before, having a solution that has Spanish available on the app, that is simple to use by the irrigator and by management on a farming operation, that there's training process and there's a training material, not that they're going to ship you a system that is not finished, that is not working, that they can't train you on how to use it, or nobody knows really how it works because it comes from somewhere overseas. It needs to have training material and a clear training process to teach you as an irrigation distributor, as an irrigation installer, how to install and operate the automation system. Then the remote support to installers and to end users. As I was saying before, we're geared up to receive 2,000 phone calls a week. And right now we got guys calling just to ask for their password, and we got other guys to make sure that the fertilizer injection on the proportional fertilizer injection is happening correctly. Also, it's important to have a platform behind the scenes. We have a platform that's running, that's constantly doing diagnosis on systems. So we are working very hardly, and we've been working and developing this for years to have a outstanding support. And that means we are telling you, dealer, when there's a problem. We're sending you a field service work description with the scope of work that needs to be done in the field to repair something, hopefully before you get a call from the grower. You will get a call from us to telling you that something's failing. That is crucial, because when something already failed, or that pump didn't start, or that VFD is not operating, then the problem, you're late. You need to be there before that happens. And then, of course, price competitive. You need to be price competitive. This cannot be something that the grower cannot afford, because what we need is profitability for the dealer, and we need profitability for the grower. And finally, stock security. We hold a big chunk of stock today in Fresno, ready to be picked up or shipped anywhere in the country for any kind of projects or service that needs to be performed. What does the distributor need to consider? Well, this is a new division. This is not the pipe and glue, this is not the emitter, this is not the filter station, this is a new division. This is the automation division, and it needs dedicated and knowledgeable staff that is trained. Again, training. And we're gonna be, well, that's one of our main requests on the integrators and distributors we work with. Get training, know what you're doing, because this is a new division for the business. And in terms of staff, usually this could be combined, but usually it's 3 different aspects. One is having the sales staff that is trained and committed, and he advises growers on what they need for what their problem is, for their need. Second, the engineers that are doing designs on the irrigation systems and understand how to cluster valves and how to design the automation solution for that irrigation system and make the best economic design in terms of pipes and electronics to make a good design of an irrigation system with automation. And finally, technicians. Having technicians that are doing clean, durable installs, that know what they're doing, that work as electricians, but understand the hydraulic. So clean and high standard installs. That is crucial. That is crucial in this business in order to be profitable. If not, you're going to have to go back there again and again to make fixes. And we've seen this left and right. We've seen boxes being left open, and so corrosion comes in, hopefully not using lead batteries anymore. These are out of the game. Using 2x4s to install an out, yeah, that's not going to last long. Or installing soil moisture sensors on a sick tree. Those are the kind of things that we need to pay close attention, because installation is 50% of the success of the project. So I was saying before, cluster valves make it economically viable, economically better for the grower. We've gotten to the point where this is very competitive, if not more cost effective than running wire to control valves in the field. And the nodes are capable to controlling up to 9 valves each one. So there is a component of design there to make a better economic decision on the blueprint. And then finally, as an irrigation dealer, understanding and incorporating soil moisture sensors into your equation. This product, this component is crucial for the irrigation decision making, for how long and how frequent I'm going to irrigate. Now, we are not asking distributors to teach growers how to irrigate. We're not asking them to teach them how to use the sensors, but to know how the sensors work, to know how to install the sensor, where to install the sensor, and do a good job at that. The grower will learn how to use it, or will have a consultant, or will hire one of these third-party artificial intelligence companies to provide an irrigation recommendation. But the sensor is a crucial component of an online irrigation management system. Okay, so I'm going to run through this fairly quick, so we don't run out of time. Pricing, we got very competitive, as I was saying before. The M1, the monitoring unit, is a unit that you can get anywhere between $650 and $950 with a subscription of $150 a year. So very affordable by the grower, very competitive with any monitoring only solution out there in the market, to put a flow meter, to put a well, to put a weather station, or a soil moisture sensor. That's there, that's available, it's competitive, and most important is compatible with controls, which is the next step on this kind of platforms. Then the C1, the controlling node, fluctuates between $2,500 and $3,000. It's a full controller, but we still make it very competitive. So it's going to be slightly above what would be a smart turf timer, but considerably low than some of the control solutions out there that are selling for tens of thousands of dollars. And then finally, the X1, which is the flexible node, which fluctuates if it's radio or cellular, or how many expansion boards it has on it. So it fluctuates between $150 and $1,500. And that is basically the unit that goes in the field. So overall, we end up seeing that the cost of investment of an automation system, including the sensors and the labor, fluctuates something between $200 and $300 an acre. Sometimes less, sometimes low. I would say an average of $200 an acre. And then the expansion modules, they're in the hundreds of dollars, both the expansion boards and expansion modules for the different models. So as an example, for example, I got here a well pump that has an existing flow meter with a filter station. We put a pressure before and after filter. It's got 4 valves right there at the filter station that we add the pressure switch to make sure that the operation is correct. And we add a Siemens weather station, considering it's in California. So a system like this would need an RFC1, a couple of pressure transducers, 4 switches. So it ends up being a total investment of $4,000 in equipment. And if you add a soil moisture sensor, considering a Centec drill and drop and an M1 unit out in the field, you add another $2,500 with a subscription service of $400 a year, a data plan of $450 a year, and the M1 subscription fee of $150. So we're talking about $1,000 a year on subscription fees. So very affordable, very competitive with what's available in the market. Another example, this is a little bit bigger with a well, existing flow meter. We got 8 valves out in the field, clusters in 2s and 4s. So we had here the X1s and the expansion boards to control the valves and the pumps, keep the transducers, but now we're looking at a $6,500 investment. And the subscription goes from $1,000 to $1,100 or $1,200. So again, it's very flexible and can go from very small projects all to big projects. Usually, ultimately, big projects end up having a lower per acre cost of investment. Finally, touching the topic of marketing and funding, this is pretty important. We have been working a lot on positioning our company as the precision irrigation alternative out in the market, precision irrigation, precision nutrition. We are very important that it's robust, it's reliable, it's reliable and durable, flexible, because it connects to other sensors. A lot of sensors is connected to third-party software, so very flexible on the integration of all sensors and softwares, affordable, because this needs to be in the range of what a farmer can pay, especially in the range of the irrigation business irrigation industry business, and locally supported, because we work with the local irrigation dealer for that grower, and that's what we're looking for, that local grower going to his local dealer to buy the automation system. And what we're doing is that we're training that local dealer to be knowledgeable on these systems. In terms of promotion, social media has ramped up, especially now with COVID. Trade shows are gone. Hope they're back soon. And dealer events, we've been doing demos, lunch-ons where we get to teach growers and get training events. Here are some pictures of some of our distributors, posting on social media how they're using the systems, monitoring reservoirs, controlling pumps, sensors, etc. And then finally, incentives. These are California examples, but this is throughout the US and throughout the world. Actually, we've seen that there are a lot of incentives for these water-saving technologies. Here in California, PG&E has several programs. The most famous one that we've used the most is ADR, Automatic Demand Response, and they basically provide money for the investment and then provide a rebate to the grower when they participate of the events of an automatic demand response. Then a very popular one, NRCS, through the EQUIP program, on their different offices are offering money both for soil moisture sensors, but in the last couple of years, they've been funding automation projects and remote control, because they've seen how that is the ultimate way to save money, to being able to execute the decisions. And then finally, it goes on and off, but the California Department of Food and Agriculture, the CDFA, through their SWEET program that I understand is probably coming back in the next year or so. But then like that, there's several ones. There's local water conservation districts. The county usually has programs that will allow the grower to apply for financing and pay for the equipment. And to wrap up here, I put this as a kind of like a summary of what the considerations for an irrigation dealer would be to incorporate automation. So in terms of the partners, the manufacturer, having the correct electricians to do the electrical work, that's crucial. Working with local universities and researchers that validate the technology, and that extension programs that will tell growers and teach growers how to use it better, sensor companies, and the third-party software solutions. In terms of key activities, training on the staff, providing the customer service, then the key resources, the manufacturer support, that's where we come in, able to support everything that the dealer is doing, and having stock on their shelves, and having the human resources ready to go. In terms of the proposition, we're telling growers that this will increase their profit, and it does. It allows them to save water, save input costs, and increase their yields. One-stop shop for all the irrigation-related needs, reliable and durable. So in terms of customer segments, we've seen a lot of the small growers jumping into this, depending on the crop, medium and large size companies as well, and ag corporations are incorporating this kind of technology at a fast pace. In terms of the cost structure for the dealers, the hardware, as I said, is a low portion of the irrigation project. The software as a service on an ongoing revenue service, and the installation, which needs to be qualified labor and ends up being something between 30 and 50% of the automation project. So that's very important for irrigation distributors. And the revenue stream is the hardware, one-time sale, like any other irrigation component of the irrigation system. But this also, we incorporate the dealer or the distributor, so he's committed with the grower, to that local grower, to go out there and help them and fix anything in the field that needs to be fixed. So the recurrent revenue subscription is built through the distributor, through the irrigation distributor. So they are part and committed to the grower to fix anything that needs to be fixed or service anything that needs to be serviced when the moment comes. That's all I got. I think I may have been a few minutes longer than you asked me to, Mike, but
that's okay. No problem, Guillermo. It was a good presentation. Just a quick reminder, everybody, that if you do have a question, type it in the question box there on the toolbar there for the webinar, and we'll ask Guillermo. And while we're waiting on that, Guillermo, do you have any kind of like quick final thoughts or just a little nugget of information you want to leave with everybody?
Yeah, well, basically the fact that this is here to stay. This is something that has made huge progress in the last 3 to 5 years. When I moved here to California, automation was not really a topic, and now it's a trending topic. So especially for irrigation distributors in general, this is something that here to stay, that growers are asking for. So it's better to learn it and incorporate it in the operation as soon as possible. And on the grower side that haven't tried it, an invitation to try it. The main thing, and beyond the water savings and potential cost savings or increase in yields, is the simplicity. Is how it simplifies the growers' lives, and they got the irrigation information in their phone. If anything's going wrong, they get an alert. So what we've seen is that basically growers tells us, hey, this technology makes our life simple.
Yeah, that's great, and just the sheer amount of data it looks like you can pull out of this is amazing, and is definitely where everything's going, and is really a useful tool in making a lot of those management decisions.
Yeah, absolutely. That's something that's going to be huge. Some of our partners are generating 500,000 data points a day. So it's and a lot of people is talking about artificial intelligence and how machine learning and artificial intelligence is going to affect ag and irrigation. And my honest opinion is that it's going to happen, but all those services are worthless if you don't have an execution platform. They'll be able to execute what that intelligence is telling you. And as I said, it's coming. It's not here yet because the amount of data that we currently have is not enough for artificial intelligence. This is data that's going to generate over the next few years until we have good data to start running AI models.
Well, thank you everybody for attending today, and wish everybody a great day. This concludes our webinar.
Thank you, Michael.